So today we have a tree, binary tree, and we ask to find if it's balanced. And that means that for each particular node, like this, we check the left depth and the right depth. And they shouldn't be different more than 1. So depth left minus depth right should be less than 2 in the absolute values. Now the solution is that first search. We have to go and we have to answer the question for each node. So this is a subtree problem. You solve this question for subtree, and this will be the entire answer. This is how recursion works. So this is the answer for particular node, and simultaneously this is the answer for the entire tree. Now what should we check? We should go and find the depth, max depth, maximum value for this node. Now to answer the question, we go and solve this problem, subproblem for this left and right nodes. This is subproblems, and they will give you depth left and depth right. Now at each position we should compare these values, and if we find that somebody is bigger than 1, we make some flag to true. So we found this is not balanced. Now let's look at the code. This is how it looks like. By default we good, and this is a helper function where we just computed the maximum depth. Here is it, 1 plus a maximum of left and right. And also we're doing this checking and rotating this global variable. This is the simplest implementation. It doesn't require any extra reasoning about the tree, just that we compute this depths. Now there is a simple golf implementation, like for example, what if we want to not use this extra variable? So let's observe the golf solutions. This is where interesting part starts to happen. First we can use a marker depth. As we return the result, this integer value, so we can return any particular value, for example some negative value -1 or very big number. So I would prefer some very big number because we're doing this maximum operation. Now let's look at my other submissions where I did this. So I use this pretty big number, it is a 2 to the power, or it's just bit shift by 30 positions, 2 to the power of 30. Now this is like marker value, and it still goes entire depth to the left and entire depth to the right. So this is not very optimal because we didn't return earlier. Now let's look what other optimizations we can make. I tried to find the minimum value for this depth, and the actual minimum is just value 12. So this is the biggest depth for this particular test cases. However, we know from the description we have 5,000, so it can be possible that some depth can be almost 5,000. Now the other optimizations, or you can also use this, like be cool. The other optimizations, okay, this is without using the recursion, we can use a stack. It's very verbose, very hard, but it can be rewarding to implement this because we don't have Stack Overflow. And now finally I found this one solution. It uses this in place modification. So we have values that we can modify, and that means we can store the values inside the node itself instead of returning the result. So that means the answer can be optimized like this. We checking its balanced left, and if it is or if it's not, we skip the right. So this is optimization, free optimization, and also we don't introduce the helper function. This is good for the code both. Now let's look at the ROS solution. The trivial implementation, we can use the result and return awk or error. I like this, it's short. However, we also can use option, and the option allows us to use some helper functions like zip. You can zip two options, and they also lazily. So if it's one option and a second is not, so we will skip this calculation. So actually not sure if we skip the second one, possibly not. However, we can, with this implementation where you can just use a question mark, it was optimal, and this solution is optimal by the lines of code, exactly one line less, but it also a little bit wider, so not superior. So that's it for today. Oh, I forgot that the second is, the first was marker and second is lazy and of the short circuit, like return earlier. Or short circuit. This is optimization, and one extra note is BFS. The BFS wouldn't solve this question. Why? Because we can have a little bit strange trees, and for each particular node, the difference wouldn't be, so this difference is a max, like this. So this is max is 3, or this 3, and this max is 2. And as you can see, we possibly can have the situation where the difference between each particular node is bigger than each particular leaf is bigger than the situation for each node. So if we doing the layer by layer scan like the BFS do, we actually can't compare this, because some leaves can be much higher, and some leaves can be much deeper, and the tree still can be valid. This is why you can't use BFS. You have to actually check and compare. However, you can use BFS to track each node depth, and then you have to check again in a DFS. So the BFS kind of useless here. I would be interested if somebody gives me a BFS solution. So that's it for today.